Okay, Assalamualaikum and a very good afternoon to all of you, ladies and gentlemen. In this session, I would like to explain to you what is the basic understanding of the calculating what we call it as a concentration. Okay, so what I have here. Okay, so we are going to discuss about the concentration calculation. So as you know, concentration calculation is one of the important mechanism in environmental assessment. So what we need to do is estimate the concentration. So in the last class, we already learned about the concentration equation, where the concentration is actually a formula related to the weight divided by the volume. So the weight is actually obtained from the laboratory. So usually is being expressed as milligram, and then the volume is actually what we sample. We sample here is referred to the air samples that we collected in the field. So it's being expressed as the meter cube. So the first question will be how many volume, and then the second question will be what is the laboratory findings based on the weight that they assess. So let us go into the question. So in the fifth lesson, we already learned about the analytical chemistry for occupational and environmental hygiene. So one of the question here that I can see that we need to do some sort of calculation. So as you know, as indicated here, this is the example of the NIOSH manual analytical method. So when we go to NMAM 0600, we can see that we have the particulate not otherwise regulated. So you can see we have here is the detail, where the flow rate is actually 1.7, and then the maximum volume as follows. So we got 1.7 liter per minute is actually the flow rate, and then we know already the minimum sample will be 20 liter and the maximum will be 400 liter. So how many samples that we need to take, or how long the pump should be operated, is actually depends on the our environmental assessment strategies. Okay, so let's have a look into the question. So the question here is actually talking about as follows. So the first one, based on the previous idea construction, develop the calculation to the following problem. One chemical, and then another one is for micro. Present your solution as 1 minute video using any social media. So what you need to do is actually just give a 1 minute video explaining about your calculation. So what is my calculation here? I got let me copy this one. So the first time is 110. Okay, so we have here time 1 is actually 110, and then the weight is 3.4, and then we have another one is actually 100. Okay, T2 is actually, okay, let me just copy first. T2 is actually 100 minutes, and then the weight is actually 3.9, and then T3 we have here is 98 minutes, and then the weight is 2.1, and then the next one is T4 118, and then the weight is 1.2. So based on this, we need to estimate the concentration. So it's very easy. The first one, we need to know the volume, because we know already the weight. The weight is given here as milligram. You can see over there, it's already being provided inside the question. So how to calculate the volume? First, you need to decide what is the flow rate. So as you know, the concentrations of the volume as follows. Volume is equal to flow rate times by time divided by 1000. So that is the formula to calculate the volume. Example, this is the 110 time. So the VI for T1 is actually 1.7 times by 110 divided by 1000. Okay, and then we need to change the volume initial into the volume correction. So how to do that? So we need to convert VC is actually VI times by PA divided by 760 times by 298 divided by TA. So let's assume this one at the 180 m or 760 milligram mercury, and then let's assume this one as the laboratory condition, which is the 25 degrees C, which is correspond to 298. So 298 is 1, 760 is 1. So what we'll get, 1.7 times by 1110 divided by 1000 times by 1 times by 1. What is actually the one here? This one is correspond to the correction for the STP. Okay, that is the basic understanding. So to make your life much more easier, let us calculate all this data using Microsoft Excel, so that you can have the very clear picture about what we discussed just now. So we go to the Google Sheet for the sake of simplicity. Okay, so just open any blank Google Sheet, and then we proceed to calculate our estimates. Okay, so the title here will be the concentration calculation. Okay, so the first one, let me just zoom in a little bit bigger. So we paste the, okay, so the first one is the volume is actually flow rate times by time divided by 1000. So let us calculate one by one. So let's say the time 1, time 2, time 3 and time 4. So all these things we name as sample 1, sample 2, sample 3, sample 4. So we got 4 samples. So let us estimate the volume for each of the samples. So let us write the time first. So this is the time correspond to each of it. So this is the time. So 98 and then 118. So let us calculate or estimate the flow rate. So the flow rate for each of the samples is, let's say, 1.7. It is being indicated by our rotameter. And then let us calculate the VI, volume initial. Is actually as follows: flow rate times by time divided by 1000. So this is our calculated VI. And then we need to do the VC. So VC is actually the VI times by what is the adjusted STP, standard temperature pressure. So as I mentioned to you before, is 1 times by 1. So this is very crucial for you to do at that also, so that you won't make any mistake. So let us calculate the concentration. So before that, we need the weight. So the weight as follows: 3.4, and then we got 3.9, and then we got here is 2.1, and then the last one but not least is 1.2. So the concentration will be as follows. The concentration is actually the weight divided by the VC, or the volume. So we got already all the weight. So this is how you want to calculate the concentration. So the last or the final argument will be, what is the TWA? 8 hours. 8 hours. So to do that, we need to use the formula. Okay, so which is, we are going to discuss it later on in the future class. So if you can come up with this kind of video that explain in 1 minute about all these things, I think you will get the idea about calculating the concentration. So this is the concentration for the sample 1 at the time 1, time 2, time 3 and time 4. So the majority of the concentration is actually above what being suggested by the OSHA here, 5 milligram per meter cube, where each of the samples is actually indicated higher. Even the samples number 4 also indicate slightly higher than the standards. And of course, if we calculate the average, I may presumably say that it's also not within the PEL or permissible exposure limit, is actually above the permissible exposure limits. Okay, that is the final remarks. Until then, thank you for watching, and if you got any question, please do comment in the down session. Thank you. Bye bye.